Hey, it's me again, and today we're talking about virtual LANs at a hackerspace. So, I would say pretty much any kind of a network without segmentation is a security nightmare. Virtual LANs is a mechanism to divide a physical network into virtual ones. It used to imply that you would have to buy a managed switch to do that, or something fancier. Nowadays, even the home wireless routers do support virtual LANs. And even in your home setting, you might want to separate trusted computers for smart TVs, and maybe even create a separate wireless network for your guests. But now let's see how virtual LANs are implemented at our hackerspace. So first up is the VLAN 1. That's the one for public wired and wireless network. We've got DHCP enabled, so you get automatically IPv4 address. We've got also SLAAC enabled, so you get the same for IPv6. You can pretty much use it to reach public internet and VLAN 20, which essentially is a public internet as well. And this VLAN is bridged to two wireless networks. We've got hackerspace.EE for modern wireless clients and hackerspace legacy for older devices. Now, this is because the access points that we have, they run OpenWRT, and OpenWRT doesn't support band steering, which is necessary to properly manage devices which are roaming between two different frequencies. But the other reason there is that you want to minimize the use of 2.4 GHz, which is crowded anyway. So under normal circumstances, everything should connect to the 5 GHz access points. But if there is something that doesn't understand 5 GHz, for those you would explicitly use the legacy network. Next up is VLAN 2, which is used for security devices. But nowadays, I would say this concerns everything that is spread out over the building, but which should not be immediately visible in a public wireless or wired network. We've got DHCP enabled here for IPv4. We use static DHCP leases. I really like it when you can just plug in those devices elsewhere and make sure that it gets a usable address with the DHCP. And it doesn't have a statically configured address that you have to guess, which is really frustrating. So in this VLAN, we've got cameras, we've got door controllers, we've got the management interfaces of the wireless access points. Since these devices share the switches that go to the public wired and wireless networks, we're considering of doing a MAC allow listing using .1x protocol. And we already have enabled password protection for the webcams. We've got door controllers using API keys to fetch the door card UID hashes. And for wireless access points, we do use SSH. But in reality, this category of devices tend to be not patched regularly. And for these reasons, you would want to keep them in a separate VLAN anyway, and not intermix them with public networks. And since we already have the static leases in place, we can easily configure DNS records for these addresses, and usually stuff is accessed by DNS names in this VLAN. Next up, we've got VLAN 20. This is the zoo. This is your default VLAN for servers in the server room. We've got DHCP enabled here for convenience, so when you do your Ubuntu server install, you get immediately usable IPv4 address that you can access from the public wireless network. We've got SLAAC disabled here because for servers you would configure IPv6 address manually anyway. And the most unorthodox thing we do in this VLAN is that in addition to a internal IPv4 subnet, we've got ENET and ELISA subnets routed into this VLAN as well. Policy-based routing for IPv6 is not supported in RouterOS 6, but this should become available with the upgrade to RouterOS 7. So what do we have in this VLAN? We've got physical servers, virtual machines, whatever front-end proxies, and we've got also the Kubernetes ingress endpoints using MetalLB here. And again, to keep things funky, this VLAN is accessible from a wireless network as well, so you can do cool stuff like connect a Raspberry Pi over wireless and have it accessible via publicly routable IP version 4 address. This wireless network, of course, is password protected. So next up, VLAN 21. That's where we run most of our infrastructure. All the monitoring stuff is here, databases, motion detection software for cameras, door controller software, and all of our web applications as well. For most of these services, you do have DNS name available, so for convenience, you can access it by name instead of an IP address. But more about these services in another talk. Next up, VLAN 23. That's where we've got server management interfaces. This is the kind of stuff that historically has been quite exploitable. You've got bugs there, vulnerabilities. With OOPSes or uninterruptible power supplies, the story is even funnier because the SNMP interface that it exposes for monitoring purposes also permits you to shut down an OOPS, which is obviously something that you don't want random person to be able to do. So for these reasons, this VLAN is reachable only from trusted segments. So VLAN 21 for monitoring and from VPN, so system administrators could access the management interfaces. We've got, again, DHCP enabled for convenience. If necessary, we'll use a static lease. There is a IP version 6 subnet configured for this VLAN, but in practice, no one uses it. That's again because the management interfaces tend to have rather archaic software deployed on them. This VLAN is hooked up to a separate physical switch, and we are juggling ideas to add LTE modem connectivity to this VLAN. So in case of an emergency, you would still be able to reach the server management interfaces even if everything else is down. Now we've got also VLAN 101. That's what we use for storage. In order to actually utilize 10 gigabits, you really need to bump your maximum transmission unit as far as you can. For most switches, it is 9,000 bytes. For some fancy ones, you can also bump it to 64 kilobytes. This VLAN is used to facilitate NFS shared file system between Proxmox host and ZFS storage machine. But more about this in another session. This VLAN doesn't make any meaningful use of DNS because we don't want to disrupt the tenant VMs even if our own DNS is down. And there is an opportunity to configure different spanning tree topology for this VLAN. So we could have the storage VLAN prefer another core switch. And the end result here would be that we would have sort of load balancing between the core switches as well. Now, if we would smash all of the previous slides into one picture, it would look something like this. So we've got VLAN 1 with, let's say, untrusted devices, anything that connects through Wi-Fi, anything that is plugged in on the wall. So we've got VLAN 2 that spreads over the floor. We've got cameras there, door controllers, the management interfaces of wireless access points. And we've got VLAN 23, which is pretty much restricted to server room only. That's where you have the uninterruptible power supply, management interfaces, and the server management interfaces. Now in the server room, we've got also VLAN 20, which is intended to connect servers, but this is also bridged to a wireless network that spreads across the whole floor. Now VLAN 21 is the one that is restricted to server room only. That's where we have our trusted services. And in the middle, we've got the router, which actually imposes all of the restrictions regarding the traffic flow from one VLAN to the other. So from that point of view, VLAN is a layer 2 isolation mechanism, but router is where the layer 3 isolation actually happens. Our hackerspace members are welcome to request their own VLANs for private use. Let's say if they have multiple servers, they want to set up an internal network between those two servers, that is possible. And we've got our ISPs as well, handled as VLANs. I believe we have point-to-point routing set up with both of them. So in order to simplify stuff, they're accessed over VLAN as well. So if you want to know more about our hackerspace and the network that we've got there, subscribe to our channel. We've got more episodes coming up on optical links, bonding, LACP, multi-chassis link aggregation. If you want to host stuff with us, or you found a security issue with our network, please reach out to info@hackerspace.ee. I'd like to thank Startup Estonia and Credex for creation of these videos, and we're hoping to make more.